Hey everybody, this is Mrs. C and I am coming to you with a video that is going to go over several things. The first thing that I want to go over is I want to just walk you through the basics of um, putting an equation that's in standard form into Vertex form. So we're going to actually be working a lot in Vertex form, working to get an equation in Vertex form, but then we're actually going to take that a step further and complete the square. Okay, so we've got a couple, I'm just going to draw a square because I'm out of space. We've got a couple things going on here, and so we're just going to jump right in. Okay, here we go. Now I'm going to start with my first equation. That's number 18. It is 2n squared plus 12n plus 10. Oh my goodness, my writing is going so slow. I don't know why. Equal to 0. All right. So the first thing we want to make note of when we are putting something in vertex form or when we're completing the square is we do not want a coefficient on our quadratic. And so I'm going to want to take care of that. But before I do, I am going to just evacuate this little constant term out of the way. Okay. I want to try to make this as clean as possible. So I'm going to have my 2n squared plus my 12n. I'm going to have that equal to a negative 10. And now I'm going to factor that 2 off so that I can actually proceed. This only works if my quadratic has a coefficient of 1. So what I'm going to do is just a quick little algebra, way back in the day, right, of algebra when we would just take the GCF out of a poly. And there we go. We have the 2 times the quantity of n squared plus 6n. Now that I have that taken care of, I'm good to kind of proceed with my process for writing a function in vertex form. And so what I need to do, because I always do this, is I actually, when I'm writing this, I didn't want to confuse you if you've never seen me do it before, I actually, I'm going to throw down a different color, add a blank right here. There's going to have to be a bunch of color changes here. And I'm going to explain why after I add a blank on the other side as well. Okay. So what I'm doing is I'm going to force this left side right here to be a perfect square. This is kind of why it's called complete the square. I'm going to force that little trinomial that's inside the parentheses to be a perfect square trinomial. And then that way I can express it in a factored form, which is also conducive to the vertex form. So what I need to do when I'm doing this, very simply, is to actually figure out what is going to go in that blue space. Well, in order to do that, you take your linear, you divide it by 2. That gives you a 3, right? And then you square that number. 3 squared is 9. So I am going to be adding a 9 into that parenthesis. And you would oftentimes just jump over here and add a 9 here, but don't. Because I really didn't add 9 to the left side, did I? Take a closer look at what I actually added to the left side. Yeah, you see it? There's a 2 on the outside. And so if I'm going to be truthful here, I didn't add a 9. I added a 2 times 9. You see it. Yeah, I added 18. 9 and 9 is 18. So I have to make sure that I account for the GCF that is on the outside of the parenthesis. And I'm sure you can already see that could be a place where you make a little mistake. And so just be careful, right? I mean, you could come over here and you could write 2 times, just to remind you to do it, or just be aware of what you're doing and always kind of double check. All right, so now that I've kept my nice little equation balanced, I'm actually just going to erase this so that I have room to write. Let's just continue on. We're so close to the end already. All right, now that everybody is cool here, we're going to actually take this little trinomial and express it in its factored form. A perfect square binomial can be expressed by taking the square root of the first term, the square root of the back term, and the sine of the center term. and then just writing that in its little binomial form, and then squaring that binomial, called the square of a binomial. If I square this binomial, I'll get right back to the n squared plus 6n plus 9. Don't forget the little 2 on the outside. And to make this really good, I want to finish the right side. Now, negative 10 and a positive 18 is 8. And to be in vertex form, and let's just identify that right now. Vertex form would have me actually minus that 8 over, and then set my little function equal to y. So I would have y equals 2 times the quantity of n plus 3 squared minus 8. That is vertex form right there. We're looking at it. And a vertex form isn't good unless you identify the vertex. And so here's my vertex, my h and my k. And I know you know you're supposed to take the opposite of whatever number is in the h position, because the formula is actually the quantity of x minus h. And so when I identify my vertex, it's really the x value is negative 3, negative 8. And if that's the first time you ever heard anything about HK, that would be confusing. So you might want to go back over and sharpen up your skills on vertex form. So I already know my vertex for this one. I'm going to write it on over here, okay? My vertex is negative 3, negative 8. But I'm not going to stop there, guys. I'm going to continue on, and I'm going to actually find the intercepts, meaning I'm going to solve. So I am going to erase. If you need to come back to this process, just rewind the video, because I'm going to have to make some space for myself here. I'm going to actually not minus the 8 from both sides. And the reason I'm not going to minus the 8 from both sides is because when I'm solving, I want to separate my letters from my numbers, right? I don't want to bring 8 over to the party that n is already having with all these other people. I want to separate. And so I'm actually going to isolate my n even further by getting out everybody that's not an n. So I'm going to start by just simply dividing both sides by 2. Now, dividing both sides by 2 will get rid of that little 2 on the outside. And that's going to leave me with the quantity of n plus 3 squared still, equal to 4. Now, remember, in the very beginning, I think I suggested that we were, maybe not, I have tried this video a couple times, but we're going to use something that's referred to as the square root method to solve, not the quadratic formula, the square root method. Because yes, we could have done the quadratic formula all along, but this is a different method. And so in order to use the square root method, I'm just going to utilize another color here. We're going to take the square root of both sides. When you take the square root of a square, you already know this. Those are inverse operations. You're going to cancel out the square with the square root, and that is going to simply just leave you the little n plus 3, no parenthesis needed anymore, equal to the square root of 4. Now, I can do that. The square root of 4 is 2. Don't forget it's plus minus 2. The square root of 4 is both positive 2 and negative 2. Last but not least, n will be by itself as soon as I minus that 3 over. So I have my n values, and I'm going to try to find a little space. I'm going to make a little squiggly line and write it here. I have n equal to, I like it written this way, negative 3 plus minus 2. It just feels better for me. There are two solutions, right? Negative 3 plus 2, which would be, n would be equal to, let's do a little set notation, little set here, a little set bracket, negative 1. That's the negative 3 plus 2. And then the negative 3 minus 2, that's going to be the negative 5 option. So those are my two solutions. So my x-intercepts are, drum roll, negative 5 and negative 1. Always wanting to be proper and put your negatives, your lowest value, your least to greatest value. So now I know a whole bunch of information about this graph. I know that its vertex is at negative 3, negative 8, and I also know that it's going to hit the x-axis at negative 5, negative 1. So a whole lot of information there for me. All right, guys, let's try another one. All right, I'm going to just erase what we got here. So again, if what you need is to go back, just feel free to rewind the video because I'm going to lose all of this. Okay, which one do you feel excited about doing? I like number, I'm looking at these. Wait a minute, what kind of problems did I get here? These aren't very nice. You can't GCF them. If you have problems like this, where when you're trying to take the value of the in out, you're going to wind up actually having to deal with fractions. I don't want to have to deal with fractions, so hold on 1 second. Okay, those are better. I didn't notice that the ones that I picked, if you do go to CUDA software and you're doing the these come off of completing the square practice, you want to make note that the bottom ones, the very ones towards the bottom, like let's see, 19 down here, if your linear term is in these cases, especially if they don't have a common factor, you're going to wind up having fractions, and certainly not the video I wanted to make this morning. So let's try number 15. This one looks cute. Okay, we have 5v squared minus 21 equals 10v. Okay, we're all out of order here, right? Let's get things in proper order. So remember me telling you the constant needs to get out of the way. And in this case, my linear needs to come over and join my quadratic. So let's just shuffle things around. We'll keep the v squared where it is. We'll minus that 10v over, and we'll actually add that 21. And if you're doing completing the square in vertex form, you can handle that little mental transposing. You know, if you're new to Algebra 1, certainly I would suggest you show your process steps. But we minused the 10v over, we added the 21 over. And now we're good to GCF. So we're going to take that 5 out, renegotiate the way things look here, like that. Okay, so I divided everybody by that 5, kept the 5 on the outside, giving me the v squared minus the 2v on the inside. Now, remember the blanks that I leave. This time I'm just going to be lazy and not color code. I'm going to say v squared minus 2v plus this blank, and that's going to be equal to the 21 plus the blank. Now, if you want to really help yourself right now, I want you to make note that there's a 5. So you might want to just remind yourself that whatever value you would add to those blanks, this right blank is going to have to be times by 5. And maybe that's a good way to keep you from making that little mistake. Okay, so now, remember, you divide by 2 and then square. 1 squared is 1. So I'm going to put a 1 there, and you could say you're going to put a 1 there, right? A 1 and a 1, but don't forget to times that 1 by 5. So that's actually going to be a 5. So that's a little extra, excuse me, I'm shuffling my position here. That's a little extra process, but maybe it's worth it, right? Because this is not the shortest process you're ever going to do. So maybe slow and steady and a little bit more process in this case is safe. I don't know. I'm making it up as I go. I'm going to erase this stuff just to give myself more room. And now I'm going to, remember, I write this in its square of a binomial form. I've forced it to be a perfect square trinomial. And now I'm going to write it as a square of a binomial. Square root the first, square root the last sign of the center term. Remember, the square root of 1 is 1. Bring the little 5 down, and then take a look at what we have going on here. We have a 21 and now a 5. 21 and 5 is 26. Now let's remember, if we were writing the vertex, or writing it in vertex form would be y equals 5 times v minus 1 squared, and I'd need to minus the 26 over, right? That would be my vertex form, identifying then my vertex of this function. I'm going to write it over there again. The vertex is my h and my k. So this is my h. Remember, it's the opposite of your h, so that's a 1 as my x, and the negative 26. It seems every time I do this, I want to put that negative 26. Your vertex is not always y value of a negative, but it seems like every time I do it, that's what I get. All right, so that's my vertex, and remember, we're not actually stopping there. We're going to keep on going, and so I want you to remember, if I'm solving, I'm actually not bringing the 26 over to join the v. I'm actually moving everybody away from the v because now I'm solving. Kind of switched my tracks a little bit. Let's divide by 5. Okay, and let's write what we have. We have the quantity of v minus 1 squared equal to 26 over 5. Fear not the fraction. Not a big deal. Don't really care that it's a fraction, honestly. I'm just changing the color just to show you my little square root right there. And that is going to give me the v minus 1 equal to the square root of 26 over 5. I'm going to write that as the plus minus. Okay, and I'm running out of a little space, and I'm trying to figure out where to move here. So if I just do myself a little squiggle here. Okay, so let's clean up. What do we have? Because I have to still, guys, I have to add 1. Okay, I have v equal to a positive 1 plus minus the square root of 26 over 5. Now that is, I know that the square root of 26 over 5 is not rational. And so I'm really tempted to leave it in this irrational state. But I do want to go over to the side just in my calculator just to figure out what exactly the answer is. So, and exactly meaning after I round it, right? So if I did the 26 divided by 5, what's 26 divided by 5? That's 5.2. So if I was to write 1 plus the square root of 5.2, I would get 3.28, blah, 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 blah. So I'm just going to write that. I'm going to round it. V equals, let's do 3.28. I like that, 3.28. And then I want to do the other version. Again, 26 divided by 5. This little inside is equal to 5.2. And that's what I'm out of space on my, hang on a minute. This is equal to 5.2. So when I'm typing it in the calculator, I'm just inserting that. It's easier to me than writing a fraction. But I have to do the negative version, right? So I have to do 1 minus. So what's 1 minus the square root of 5.2? That's going to give me a negative 1.28. Okay, negative 1.28. Negative 1.28. And whenever I'm doing, which is going to be totally transparent, whenever I'm doing a video and I get one that doesn't work out so super pretty, I always pause and double check. So let me just make sure our answers are right. And they are. What a great feeling, right? When you get something like this, you're not always feeling warm and fuzzy. So these are the V's. Now, the V's, remember, are where the function hits the x-axis. They're my solutions. And so when I'm graphing this, I am aware now that my V, or my x-intercepts, that's what I'm going to write here, my x-intercepts of this graph, if I was graphing, would be at, let's go smallest to largest, negative 1.28, and the other one would have been a 3.28. That's where they'd be hitting the x-axis. And remember, our vertex was at 1, negative 26. Okay. Woo! All right. Not the easiest, certainly not the hardest, just a nice in the middle kind of a problem. Again, all good methods. There are other ways to do it, guys. There is certainly the way when you have a quadratic, you use the quadratic formula. If you want the vertex, you use the vertex form, which is x equals negative b over 2a. And then you use that x to get the y. You get the vertex that way. There's lots of ways to do things in math. This is just one of them. And you know what? There's more. So let's do more together in the future. I'll see you on the flip side.